Ali. Not all, thank you. Not all. Lele. What ma fẹ́ mo fẹ́ ṣe kíní kan. Méjì mo fẹ́ ṣe. Méjì mo fẹ́ ṣe.
Ìwé ṣí méjì sílẹ̀.
Mo ṣí méjì sílẹ̀.
Tó bá ti fẹ́.
Ma fẹ́ ṣe. I don't know if
Start now.
Not all. Not all.
What's the name to
Mo fẹ́ gbé lẹ́sẹ̀ bí mo ti gbé sálẹ̀. Sit down. Someone come and raise up their hand. I'm very.
Anyone that can feel that.
Can I be there?
She.
Wọ́n fẹ́ béèrè question. Okay, màá kàn lọ sí more. I will be seeing it.
More than
chat.
Chat.
Okay.
Anybody be a question?
Okay. Okay.
Thank you.
Yes. Yes. Good afternoon, students. Thank you. Welcome back to physics class. But today is 7/11. I want to revise our last lesson before going to the new topic. If you recall, last lesson, we said something about the third law and conservation of linear momentum. If you recall, we said third law of motion can be stated as what? To every action, there's an equal and opposite reaction. Also, from there, we generate a formula that to be equal to FA equals to minus FB. I mean, to every action, the force you exert on the particular object B, you are exerting the force, the force A is exerting the force A on the B, force B, and the pain you feel, that's the negative sign. That's the pain you feel. That's how we arrive to this. But from the conservation of linear momentum, it has three principles. The first one, in any closed or colliding object or system, the momentum is always conserved. We also have another one. That if two or more bodies collide in a closed system, the total momentum before collision must be equal to total momentum after the collision. We prove out the formula from the second and the third Newton law of motion. Where we arrive to is this. It said MA UA plus MB UB equals to MA VA plus MB VB. I think this is where we stop last lesson before the example. the MAUA plus MBUB stand for the total momentum before the collision. Since U is the initial velocity for the two objects to collide together, U is the initial velocity. That means this one now, this one, MAUA plus MBUB is the total momentum before collision. Before collision. MAUA plus MBUB, total momentum before collision. That means the MAVA plus MBVB will be total momentum after collision. After collision. I think that way. And another thing you need to know there is that if an object is moving along the right path, along that direction, your U will be positive. U will be positive. U will be positive. Well, when the object is moving along this towards the left side, your U there will be negative. When the object is moving along the left side, U is negative. While it's moving along the right path, your U is positive. You need to know that before the example. For the example. Now, according to the question, our last example, let's revise the example before new. Yes, this example, an object of mass 5 kilograms moving with a velocity of 12 meters per second. An object of mass 5 kilograms moving with a velocity of this. That means the mass of this is the mass 5 what? Let the mass of this object be 5 according to the question given to us. 5 kilograms moving with a velocity of 12 meters per second. That means the velocity in which this thing moves takes to move. U there is 12 meters per second. Are we together, please? Now, the next said, due to not, it's a stationary ball of mass this. It's stationary ball of mass. The mass of this one is what? 7 kilograms. But it's stationary. As it is, it's at rest. That means your U is 0 for that particular one. But let this one, mass of the object, let it be MO. Are we together? It's a stationary ball. A stationary body. Let that one be MB. Then I said, if they stick together after collision, both of them now, the 5 and the 7, stick together after collision, calculate the V. That means this one now, the mass is there with what? The other will be the mass. 5 plus 7. Since they are together with the same velocity, which is V. Are you together, please? No, you will not. Now means 5. Mass of the object is 5. The initial velocity of the object is 12. Mass of the body is 7 kilograms. The initial velocity of the body is at rest. That's 0. They stick together. Look at they stick together. That is the addition of the mass with the common velocity V. Then allows us to determine the common velocity. Also, if you recall, common velocity means when your VA equals to VB equals to V. We derived the formula last lesson that your common velocity equals to what? MA. But this one we are using two things. We are using object and the body. It will now be mass of the object, U of the object, plus mass of the body times what? The U of the body over the addition of the two masses over the mass of the object plus mass of the body. I think that's what we did last lesson. Now, mass of the object. What is the mass of the object? 5. That's 5 times initial velocity of the object is 12. Plus mass of the body is what? 7. Initial velocity of the body is at rest. That's 0. Over what? The addition of the two masses. 5 plus 7. This one is 60 over 12. I think you will get 5 there. 5 meters per second. I think this is where we stop last lesson. This is where we stop last lesson. The example 1. Sorry, example 4. The common velocity now equals to 5 meters per second. Common velocity equals to 5 meters per second. Now let's look at the example 2. Let's look at another example under collision. A body P of mass 0.25. Solution to example 6. A ball P. A ball P is the mass of this one of what? P. That is MP. MP is 0.25 kilogram. Loses 1/3 of its velocity. Loses 1/3 of its velocity when it makes a head-on collision with an identical ball Q. Identical means that another object, another ball, Q, mass of Q, since it's identical, that means the mass of P will be equal to mass of Q. That's what they're saying. That means this will also be 0.25 at rest. That means the object is at rest. That means your U here is 0. But what happened to the first one? They said lose 1/3 of its velocity. That means for UP, we don't know it. We don't know it. As I said, it makes head collision with an identical ball Q at rest. You can't see. Thank you. Sorry. Please, what about that? Okay, thank you. Now, what we are trying to say is this. The mass of P is given, and mass of Q is identical with that mass of P. That means the same thing. Then I said, mass of P loses 1/3 of its initial volume. That means initial volume is U, we don't know it. Then I said, when the object B, the object Q is at rest, that means your UQ is what? UQ is what? 0 at rest. After collision, what happens after collision? They say after collision, Q moves off with a speed of 2 meters per second in the original direction of P. After collision, both of them, they are now moving in the direction of what? Of that Q. Okay, now let's see the diagram, please, for that one. Having the same mass, don't forget. But for VP will be what? They said loses 1/3 of this original one. That means this one will be what? U minus 1/3. 1/3 initial velocity of ball P. Lose what? 1/3 of it. That means U minus 1/3 of that. That one will be what? Vp is equals to 2/3 U. If you work it out along the direction. For P, this is body P. Now for Q, what happened? They said VQ, what is the value? Q moves off with a speed of 2 meters per second. That means the velocity, the final velocity of Q is 2 meters per second. Can you see the diagram, please? Again, the mass of the ball of P is 0.25. Since they are identical, mass of Q also will be 0.25. The now said, mass of P, the initial velocity of P loses 1/3 of the initial velocity, loses 1/3 of it. That means UP is U. UQ is at rest, 0. The 1/3 that this one loses, that means you need to remove 1/3 from the initial velocity. That's U minus 1/3. That one will give us 2/3 of the U. The final velocity of Q is given as 2 meters per second. The now said, calculate the initial velocity of P. Calculate UP. That's what they are saying. Calculate the initial velocity of P. Calculate the initial velocity of P. Is it okay like that? Calculate the initial velocity of sheet 2. Is it okay? Thank you. Calculate the initial velocity of P. I want to clean, please. I want to clean, please. Yes. Now, from the formula, from calculation of linear momentum says that what? The total momentum before collision must be equal to total momentum after the collision. Total momentum before collision equals total momentum after collision. After collision. Total momentum before collision, what is the formula? MP UP plus MQ UQ equals total momentum after collision is what? Total momentum after collision MP VP plus MQ VQ. Are we together? After collision. That means the MP, what is the value of, but they said since MP and MQ, they are identical. They are the same thing. They are the same thing. Since P and Q are of the same mass, that is MP equals to what? MQ equals to M. That's what they are trying to say there. Since MP and NQ, they have the same mass, they are identical. And the value of MP is equal to the value of MQ equals to a single value, M. That means the formula now will change to what? Here now, let's write the formula. It will be what? MUP plus MUQ equals to the same thing applicable here, MVP plus MVQ. Something is common. M is common. That means we have now M into bracket of UP plus UQ. Also here too, M into bracket of VP plus VQ. Are you following, please? Divide both sides by M. What happened? M cancel M here. M cancel M. M cancel M. What do you have left there? We have UP. We now have UP plus UQ equals to VP plus VQ. Now let's put the values. What is the value of UP in the equation? Value of UP in the equation is what? Unknown U plus value of UQ in the equation is 0 because it's at rest, equals to value of VP in the equation is what? 2/3 of U plus value of VQ in the equation is given as what? 2. Collect the like times. Bring this to the other side. It's change to negative. Change to minus. That means we have U minus 2/3 U to be equal to what? 2. This one, if you remove this one from here, what do you have? You're supposed to add U/3. I mean 1U/3 equals to 2. Remove this one from here. Just find the LCM. Just find the LCM. This one over 1. The LCM is 3. 1 and 3. That's 3. 3 times U. That's 3U. Let's work it out. Let's write it. Body is writing something. Sir, it's 1/3. Yes, it's 1/3. Remove 1/3 from the initial. That's U minus 1/3. It will give us what? 2/3. Remove 1/3 from initial. It will give us 2/3. Then 2/3 is left. Thank you. Thank you. Move. Can we move on now? Thank you. Remove 1/3 from the initial. It remains 2/3. Now the LCM is what? 3. 1 and 3. That's 3 times U. That's 3U. Minus 3 and 3, 1. 1 times this. Now you have 2U equals to 2. What do you have left here? We have U, 3U minus 2U. See, it's still the same thing as 1U/3 equals to 2. Your U now will be equals to what? 6 meters per second. So you cross multiply. I mean, your initial velocity they want us to determine is what? 6 meters per second. Yes. Clear? Counter. Yes, thank you. Yes. We have this. Please question before we move on, please. Please ask question before we move on. Ask question before we move on.
You can ask also, they'll answer from here, from chat.
Not see their image, whether they are seeing it. Yes. Play now, please. Six meters per second. 6 meters per second. Total momentum before. Don't forget, when an object is opposing, imagine opposing. Opposing means now you are going on a straight line from that diagram. You are going along that path. You carry a positive charge, a positive. But when an object is opposing it, that will carry what? A negative sign. That will carry a negative sign. Please note that inside this particular question. Clear, please. Now let's move on, please. Total momentum before collision must be equal to total momentum after collision. They may use any letter. They may use 1 or 2 or figures. They may use letters P, Q, A, B. Any letter they can use. Please, just note, please. Now let's look at this. at the second question. Let's try this. Let's see whether the question says what? A body P of mass 5 kilograms. That means the mass of P is 5 kilograms. It's 5 kilograms. Question. I don't understand. This is Alima, Umar. Okay, let me summarize the question again. Let me summarize the question again. Let's go back. But please listen very well, please. Very, very important. A ball P, now mass of P is 0.25. This is 1/3 of its velocity. That means the initial velocity of that P is U. When it takes a head collision with an identical means the mass of Q also will be equal to the mass of the first one. That means MQ and MP, the same thing. At rest, but the initial velocity of Q is at rest, is 0, it's not moving. That's what they are trying to say after the collision. They now said Q moves off with a speed of 2 meters per second. That means the final velocity of Q is 2 meters per second. What will be the final velocity of P? They said loses 1/3 of its velocity. That means the initial velocity of P, U minus 1/3, because it loses 1/3 of its initial velocity. 1/3. That's U minus 1/3. That will give us 2/3. That's 2/3 of the initial velocity for the final velocity. That's what they are trying to say there. Are we together? And since mass P and mass Q, they're identical, they give the same thing. They cancel each other. That's what we are trying to say. Ah, you are late too. I didn't know. We are still under conservation of linear momentum. I just gave an example from when we stopped last lesson. I first summarize the last topic and give an example, more example on that. Now, you must know that the total momentum before collision must be for initial. After collision must be for final. For initial, for this particular object, that means MP UP plus MP, plus MQ UQ. They are using P and Q. That's total momentum before collision. Total momentum after collision will be MP VP plus MP plus MQ UQ. That's after collision. But from the question, the UP is unknown. We are looking for it. It's U. We are looking for it unknown. VP, since they said loses 1/3, that means that one will be U minus 1/3, 1/3. Just calm down, you understand it. Let me do it again, please, but very, very important, please. Mass of P, according to the question, mass of P is 0.25. 0.25 kilogram. Mass of P. Identical value for Q. Mass of Q also 0.25. 0.25. The next said the Q is at rest. That means your initial velocity of Q is 0. The next said loses 1/3 of its velocity. That means for P, you don't know it. UP is what that loses 1/3, but you don't know the initial velocity or no. I'm already explaining. The topic still remains conservation of linear momentum. I didn't know. Conservation of linear momentum. I'm already explaining the example for those that said they didn't understand. I'm explaining the example 5. For those that said they didn't understand, I'm explaining the example 5. I'm explaining the example 5 before the classwork. There's classwork, but I'm explaining the example 5. Just listen, please. Thank you. Don't worry. Let me continue. I'm explaining it. Now, they said MP is given as 0.25, loses 1/3 of his initial velocity. We don't know the initial velocity. That's U. They now said MQ is identical with the MP. That means MQ also 0.25. But they said it's at rest. Q at rest. That means UQ will be 0. UQ will be 0. The next said after the collision, Q moves up with a speed of that. That means after the collision, the Q now, VQ, move with a velocity of value of what? 2 meters per second for Q. What will now be for P? VP. They said loses 1/3 of, that means it will be U minus 1/3. This one over 1 over 3 over 3. This one will be 3U minus 1. What do we have here? We have 2U over 3 for what? VP. That means you can write 2/3 U, 2 by 3 U for the VP. Now we are trying to say. Now, we now said from the formula that says initial total momentum before collision is what? MP UP plus NQ UQ equals to MP VP plus NQ VQ. Are we together? From there, since this and this, they are equal. Since MP equals to MQ equals to M equals to M. That means here now, what do we have here? We have MUP plus MUQ equals to MVP plus MVQ. Right? Something is common here. M is common. Remain UP plus UQ here. Something is common here too. Equals to M into bracket of VP plus VQ. M cancel M. M cancel M. What do you now have left there? We have UP plus UQ equals to VP plus VQ. What do we have left? We have UP plus UQ equals to VP plus VQ. What is UP? U plus what is UQ? It's at rest 0. VP is what? 2/3 of the U now. Plus what is VQ is given as 2. Please, can you see it, please? Hope you can see now. Sorry for. Now, collecting the line times, that means this one will be U minus 2 over 3 U equals to 2. Right? This one now, we have U over 3 equals to 2. Here now, if you cross multiply, you have U equals to 6 meters per second. I think it's okay now. That's the another explanation to that example 5. Now, please, let's try this within 2 minutes. Let's try this question within 2 minutes. Now, let me summarize the question. The question says a body P of mass 5 kg. That means the mass of P is 5 kg. Moving with a velocity of 30. That means the initial velocity of P is 30 meters per second. Collides with another body Q, moving opposite direction. It's moving opposite direction. The sign, note about the sign, note the sign, please. Direction with velocity of moving opposite direction, yes, with a velocity of 20 meters per second. If both of them now moves in the direction of P at a velocity of 10 meters per second. Calculate the mass of Q. Just send the answer to me. I will see it. Send the answer. Please, can you see the question? Somebody said the answer is 15. Let's see. 10, 15. Ah, how come? But no pointing again. Opposite. It means that one carry negative sign. Which one carries negative sign? Q. The UQ is minus. We saw it move in opposite direction. Consider that when you are solving, please. Note, please. Very, very important. Yes, okay. You have tried, but let's, okay, we still have some minutes. Be fast, please. I'm still waiting for the response. Another person again. Now let's do it together. Three person raise up their hands. Please type. What is the question? Type your question, please. For those students that raised up their hand, please. Okay, Ismail Mustafa, 10 kilogram. Muib, 15. Alexandra, 20 or 5. No, just give us one answer. Carter, 15. Okay, let's do it together. Thank you for trying. Let's do it together. Thank you. But let's see. Let's see the answer. Let me show you the answer. I don't know. It's no problem. No problem. We do 34. She just said 34. Let's see the answer. The answer here is what? 3.3. Let's work towards that. Now, mass P. About this. What's that person again? 10 over 3. 10 over 3, I think, is 3 point. Who's that person? Who's that person? Mohammed. Thank you. Mohammed, yes. Shitu, don't say that again. Very bad. Please don't say that again. Alexandra, 3.3, yes. Okay, now let's do the solution together. Let's do the solution together. Thank you, everybody. Let's do the solution together. Solution. According to the question, mass of P is given as 5. MP is 5 kilogram. Velocity of, that means the initial velocity of what? Of P, UP, is 30 meters per second. Collide with another body, Q, moving opposite direction with the velocity of that. That means, but we don't know the mass of Q. Abi? Opposite direction. That means the mass of the initial velocity of Q is now given as what? As 20. The initial velocity of Q is 20. UQ is 20, but it's in opposite direction. They now said if both collide, if both body now move in the same direction as P at a velocity of 10 meters per second. What they are saying is that VP equals to VQ equals to what? V, which is equals to what? What's the value? 10 meters per second. That's what they are trying to say. Calculate the mass of Q. What's the formula? Total momentum before collision. Total momentum. Total momentum before collision equals to what? What's the formula? MP UP plus, supposed to be plus, Abby, but they said moving opposite direction. That will give us minus. Not that, please. Moving opposite direction. Minus NQ UQ. Now, NP, what's the value? 5 times UP, 30, minus MQ unknown. UQ is what? 20. That's 20 MQ for what? Total momentum before collision. Now, after collision, let's see. After collision, what's the formula? They said both of them, they collide, they now move in the single unit. That formula, that one will be what? That will be what? MP, right? VP, isn't it? Plus MQ, VQ, isn't it? Yes. But for this one, what is MP? MP is 5. 5 times. What is VP? The same value, 10. Plus MQ unknown. VQ is what? Wait. VQ is what? Let's see the question, please. VP. Yeah, somebody's asking a question. What? If you hear me. So I can't see the book. I think it's. Sorry. Is it clear now? Can we see the board now, please? That's the board now. Now, MQ, we don't know it. We are looking for it. VQ is what? VP and PQ, they are the same. That's 10. This one will be 10 MQ. This one give us what? This one give us 50 plus 10 MQ. 50 plus 10 MQ. This one give us what? This one is 5 times 30. That's 150. 150 plus minus 20 MQ. Total momentum. Now, from total momentum before collision equals to after collision. Before collision, equal the two. Before collision equals to after collision. Before collision equals to after collision. Before collision is what? 150 minus 20 MQ. After collision is what? 50 plus 10 MQ. Collect the line times. Take this one to the other side. That one turn to what? That's 150 minus 50. That's 100. Right? Equals to, take this one to the other side. What do you have there? That's 20 plus 10 of MQ, isn't it? 20 plus of MQ. This one is 30 MQ, right? The board is not clear. Let me check. Wow. Study. Safis. Oh, reflect. No, you can't see it. You can't see the board there. Don't worry. Sorry. Okay, now according to the question, 100 equals to 20 plus 10 MQ. Now, make your MQ such a formula. It's what? 100 over 30. Then your answer. You need to get your MQ now that we are looking for. Give us 3.33 kilograms. That's the mass of the Q. Thank you. Sorry, Miriam. A full star. Are you too? Check now. Is that different now? Sorry.
Yeah.
Miriam, sorry, eh? They are different now.
Yeah.
Have you? Sorry.
It's time. It's time now.
Don't close it.
Don't close it.
Okay, that's the answer to that classwork. Now let's take this home as an assignment. Let's try it. Let's take this home as an assignment. Let's try it. Sorry, Miriam. It's an assignment. What is the question? The question is a submachine gun of mass 20 kilograms. A submachine gun of mass 20 kilograms fires a bullet of mass 100 gram due south with velocity of 250 meters per second. What is the recoil velocity of the gun? What is the recoil? The opposite direction. That's what they are trying to say about the third law. Third law is what? You get? You feel the opposite part. No, Miriam, what do you mean? You can't fail. Just try as much as possible to try it. Hope you have your textbook with you. Go back to the question, go back to the notes, check the proving, the example given to you, and use that idea to solve this. Please, Miriam. Sorry, please. You can send it to NTI SS2 class, or to my mail. You have my mail in the first class, or like4mom@yahoo.com. I'll send your answer to it. This is your first class. What do you say? Please ask question before we move on, please. Before we go for today. Our next subtopic is elastic collision. Collision is the topic. Go and read on that before next class, so that when I'm explaining the class to you two, you understand better. Please. Please read on the next topic before the next class. Collision is the topic. Two types of collision. We have elastic and inelastic collision. Thank you. I should explain again, no problem. I will do that next class. But please try to digest it first before next class. When you come back to next class, I will explain, then we'll move on to the next topic, Miriam. Okay, bye-bye. Good night. Next week, I'm going to meet next. But please, make sure you read the question. Read everything, Miriam, and I will explain. You don't understand. Type what you need to send it to my mail. Anything you need, send it to my mail, Miriam. Or like4mom@yahoo.com. Resume next week. No, it's Miriam. Okay, please. And others too, if you don't understand, send it to my mail, no problem. Thank you. Bye-bye. Yes, no problem. NTIC SS2, not NTIC Ogun. NTIC SS2.edu.ng. Okay, please. Ogun SS2 at NTIC.edu.ng. You can send the answer to that mail. Ogun SS2.ntic.edu.ng or to my mail. Yes, Ogun SS. Thank you, Carter. Thank you, Carter.